Okay, so we are doing the third chapter of geometry. We are starting with the third chapter of geometry, and the chapter's name is circle. Okay, so we have already heard this word before in our previous standards. We'll just do some revision of circle and what are the parts of a circle and what are the properties of different parts of the circle. Now suppose I draw a circle here. So what all is there in this circle? First thing, chord of a circle. Now what is the meaning of a, suppose I join 2 points on the circumference of the circle. Now in definition, a line segment joining any 2 points on the circumference of the circle or any 2 points on the circle is called as the chord of the circle. So let me name this chord as chord A, B. Okay, this is a chord. Now we know some more properties of a chord. Suppose I name this as your center and I join 2 points on the circle but passing through the center. Then what is that called as? Can anyone unmute and tell me what is this called as?
Diameter.
Correct. Very good. Whoever said diameter. Okay, so AC is the diameter and diameter is called as the longest chord. Longer than diameter there is no chord. So AC also is a chord, AB also is a chord, but AC is also called as diameter. Okay, two circles, if they have the same measure, they are called as congruent circles. Remember all these properties. I'm just doing a revision. Two circles, if they have the same measure means what? They will have equal radii. Okay, now let's define and see what is the difference between radii and radius. Can anyone guess and tell me what is the difference between radii and radius? Can anyone guess?
Radii is plural of radius.
Yes, perfect, Dheeraj. Radii is plural of radius. One is called radius. More than one radius is called as radii. So two circles having equal radii are called congruent circles. Then intersecting circles. Suppose I draw two circles here like this. Okay, are they intersecting each other? Yes. Two circles, if they're in the same plane means on the same flat surface. Now if you see here, whatever is on the screen is a flat surface. So two circles who are in the same flat surface, they are called as coplanar circles, and coplanar circles have 2 points in common. Now if you see, there are 2 points in common here. One is this point and one is the other point. So they are intersecting at 2 points in common. So such type of circles are called as intersecting circles. Okay, so we learned about chords, diameter, radius, congruent circles and intersecting circles. Now let's do some revision of your 9th standard. In your 9th standard, you all studied certain things of a circle. Segment joining the center of the circle. Suppose this is your center. So segment joining the center of the circle and the midpoint of the chord. So suppose there is a chord here and the midpoint of the chord. So segment joining the center. Suppose we name this as the center O. We name this as OM. We name this as A. We name this as B. So suppose there is a segment which join the center of the circle and the midpoint of this chord. Midpoint of this chord means AM is congruent to MB. So such type of a segment is perpendicular to the chord. Okay, this is again your revision of your 9th standard. You had a theorem which was related to this. Segment joining center and midpoint is perpendicular to the chord. So always remember, whenever you get any sums, where there will be a center, will be a circle, and there will be this which is perpendicular, then it will be this midpoint. And if it is midpoint, suppose M is the midpoint, so OM is perpendicular to AB. Okay, so this is your property. One more property we have learned in your 9th standard. What is that property? Chords of a circle equidistant from the center are congruent. Let me illustrate by drawing an example. Chords which are equidistant. Now these are two chords here. Okay. Suppose they are distant from the center. Suppose here there is a center, and here also. Suppose I name O as the center. Okay. This is AB and this is CD. So chords of a circle equidistant from the center. Chords of a circle equidistant from the center means this distance and this distance is equal. Let's suppose we name this as OM and ON. So if OM is congruent to ON, that means if they are equidistant means their distance from the center is the same. So suppose OM is equal to ON, then such type of chords, that is, here what chords are there? AB and CD. So AB is also congruent to CD. So if OM is equal to OM, then AB is congruent to CD. Okay, this is all your revision of your previous standards. There is two more theorems which you all did in your previous standard. Same theorem but converse. Now here what they had given, if equidistant then chords congruent. Converse will be what? If the chords are congruent, then the chords are equidistant from the center. Okay, so that means if AB is congruent to CD, then OM is equal to or OM is congruent to ON. This is the converse, same thing. Perpendicular drawn from the center of the circle to the chord bisects the chord. This is the converse of this theorem. In this theorem, what I had told before, if OM is your point from the center to the chord, and if AM is congruent to MB, then OM is perpendicular to AB. Converse will be what? If OM is perpendicular to AB, then AM is congruent to MB, or in theorem language, if we say perpendicular drawn from the center, perpendicular drawn from the center of the circle to the chord bisects the chord. Okay, what is the meaning of the word bisects? Bisects means divides the chord or divides anything into two equal parts. So OM bisects AB, point M bisects AB, that means AM is congruent to MB or AM is equal to MB. Okay, the next and the last revision part, concentric circles. What is the meaning of concentric circles? Suppose I draw a circle like this here. 1. I draw another circle inside. 2. Suppose I draw another circle inside. 3. Okay, suppose I draw another circle inside. 4. So all these circles are called as concentric circles. Why? Because they have the same center. All these circles, their radius will be here. This will be the radius here. This will be the radius here. This will be the radius here. But whatever the radius will be, center will be the same. So such type of circles are called as concentric circles. Okay, so till here, if you understood, please give me a thumbs up. Please give me a thumbs up if you understood till here. I cannot see a thumbs up. I think please type clear in the chat box if you understood. That will be better. Please type clear in the chat box. Okay, great. Okay, great. Thank you. Thank you. Okay. Okay. So now we are doing the first theorem of this chapter, and we call it the tangent theorem. Okay. Now, what is the meaning of the word tangent? Suppose I draw a circle here. Please take this down. Very important. Please write it down. A line which touches the circle, I'll also write it, but you can take it down easily. What is a tangent? A line which touches the circle only in one point, or in one and only one point, is called the tangent to the circle. Okay, so if you see in this figure, if I draw, so if you see here, this line is touching the circle at one and only one point. Suppose we name this line as AC. So M is the point of contact. M is called as your point of contact. Okay. Similarly, we have one more thing. Secant. Please take the definition down of secant also. Secant. A line which intersects a circle in 2 points is called a secant. Okay. Somebody has unmuted themselves. Please mute yourself. Now, what is the meaning of this? Line which intersects the circle in 2 points. So we'll draw simple. If you see this line, it is intersecting the circle in 2 points. Let's name this line as PQ. So it is intersecting the circle at 2 points, one in this point and this point, R and point S. So intersecting circle is called a secant, and touching the circle is called as a tangent. Okay. Please type clear in the chat box if you understood till here. Please type clear. Okay, great. Anyone has any doubt at that moment, only unmute yourself and ask me. Okay.
Yes, Glen. Yes, Glen.
Okay, Padmaja, your yes was very energetic. Very nice. When you said yes, Glenn, we all were filled with energy. Can you all see the screen clearly? Can you all see the screen clearly? Yes or no? Yes, yes. Okay, great. We are doing the first theorem of this chapter, and we call it the tangent theorem. Okay, now we are using the method of contradiction in this theorem. Let me write this word first. What is the meaning of the word contradiction? Does anyone know the meaning of this word contradiction? Please unmute and tell me. Anyone knows? Anyone knows? Nobody knows. Okay. Contradiction means what? Suppose I give Soham, I keep two pencils in front of Soham. Okay. And I tell Soham, from these two pencils, Soham has lost his pencil. So but he has lost only one pencil. So I keep two pencils in front of Soham and I tell him, Soham, from these two pencils, one pencil is pencil A and the other pencil is pencil B. Now Soham, I tell him that Soham, from these two pencils, one is your pencil, which you have lost. And Soham will ask me, so which pencil it is which I have lost. So I will tell him, Soham, I will not tell you the pencil which you have lost, but I will tell you from these two, the pencil which you have not lost or the pencil which is not yours. So if I tell him that pencil A is the pencil which you have not lost, will he be able to guess the pencil which he has lost? Please type yes or no in the chat box. Yes. Okay. So I don't tell him directly the answer, I tell him indirectly. From the two pencils, I tell him that pencil A is that you have not lost. So I'll tell him which is the pencil you have lost. So he'll say yes, so obviously pencil B. Okay. Understood? So this is called the method of contradiction. We prove the opposite as not true. As I said here, pencil A you have not lost. So obviously pencil B is the answer. So same way in the method, you'll have many theorems in which you'll do method of contradiction. So in the method of contradiction, we prove the opposite property as something which is not true. So if the opposite is not true, so obviously the original will be true. Now this is a very important theorem. Let's start. A tangent at any point of a circle is perpendicular to the radius at the point of contact. A tangent at any point on the circle. Tangent at any point on the circle means yes. This is your tangent. If you can see the figure, I can zoom also a little bit and see. Line L is called as your tangent. This tangent is touching the circle with center O at point A. And point A is your point of contact. Point of contact means where the tangent touches the circle, it touches at only one point, that is your point of contact. We have to prove that line L is perpendicular to radius OA. This is what we have to prove, that line L is perpendicular to radius OA. Okay, so now let's prove the opposite. Let's prove that the opposite is not true. See what they've written. Assume that line L is not perpendicular. Let us assume that line L is not perpendicular to OA. So if line L is not perpendicular to OA, so there might be something else that is perpendicular. If OA is not perpendicular, there might be something else. What will be that something else that will be perpendicular? We assume that OB is perpendicular. We assume that OB is drawn perpendicular to line L. So you can see in the figure here down, we draw OB perpendicular to line L. Okay. Now OA is different obviously and OB is different. So if we transfer the same thing in this figure, if we are drawing OB perpendicular, so obviously we have to draw OA little far than B. They both can't be the same point. So we draw OA that is not perpendicular. Okay, we draw OA and we take a point C here such that BA and BC are equal. We assume a point C here such that BA and BC are equal. Okay, I repeat once again. OA, we have to prove that it is perpendicular to line L. But we are proving that suppose it is not perpendicular. Assuming. Suppose it is not perpendicular, so we'll have OB. Something else we'll have, no, obviously perpendicular. So if OB is we are drawing here, then OA we have to draw far. A will not be perpendicular. B and A cannot be the same point. So we draw A little far than B. And whatever distance is here, we take another point C here. Okay, now pay attention. Now in triangle OBC and OBA, there is OBC and there is OBA. Two triangles here. BC and BA are equal. Yes, construction we just did. OBC and OBA are perpendicular. Why? Because B is perpendicular. How B is perpendicular? We assume, no? Suppose OB is drawn perpendicular. So we assume that suppose OB is perpendicular. We have to still prove here, but we assumed here. Suppose B is perpendicular. So we have two right angles, angle OBC and angle OBA. Both are right angles. OB is congruent to OB, common side. Therefore, both the triangles are congruent by SAS test. So if there is congruence, so we have something called as, they are not written here. If you have the textbook in front of you, or just write it in your notebook when you're doing the theorem, if you write this, OC congruent to OA. Reason is, if you remember, we had done in the previous standard, CSCT. Does anyone know the full form of CSCT? Does anyone know the full form of CSCT? Please unmute and tell me.
Yes. Congruent sides of corresponding
No.
sides of congruent triangle.
Yes, corresponding sides of congruent triangles. What does it mean? If two triangles are congruent, so their corresponding sides and their corresponding angles both become congruent. Okay, all the remaining sides and angles also become congruent. So we proved here, pay attention now, we proved here that OC is equal to OA. Okay, we proved here. Now see what changes happened. If we are proving that OC is equal to OA, if we are proving that OC is equal to, 1 minute, okay, we just proved that OC is congruent to OA here, right? But if you see in the question what is given to us, that OA is the radius, correct? OA is the radius. It is given to us in the question. Yes or no? Let's see. Yes. A line is tangent to the circle with center O and point of contact is A. So that means OA is the radius. It is given to us in the question. So if it is given to us in the question that OA is the radius and we prove that OA and OC is equal, so that means OC also is the radius. Correct? If OA is the radius and OC also is the radius. But there is one more problem that has happened. If we are saying OC is the radius, so C also lies on the circle. Obviously, if there is a radius, that means the center is inside a circle and the other point is on the circle. Suppose this is your circle, and if I say OA is the radius, so that means A is on the circle. And now I prove that OC also is the radius. That means C also is on the circle. Correct? That means line L intersects the circle in two distinct points A and C. That means line L intersects the circle at two distinct points. That means I have proved here that there is one line L which is passing through both these points. This point also and this point. Why I prove? Because there are two points at which there is radius. No, A also is radius and at point C also is radius. That means there is a line L. But what we did just now in our previous slide, we learned what is a tangent and we learned what is a secant. Secant is a line which passes through the circle at 2 points. Tangent does not pass at 2 points, but here we prove that this passes at 2 points. That means here we have proved that this line is a secant. But in the question, what is given to us? In the question, what is given to us? Tangent. The question it is given to us that this line is not a secant, this line is a tangent. So therefore, it intersects at only one point. Therefore, our assumption is wrong. Our assumption is wrong. So there is only line L that is perpendicular to radius OA. Please let me know if you have any doubt. Please let me know if you have any doubt. I will just minimize the screen for you. I will just minimize the screen for you. So that
Yes,
you can
Glenn.
have a look at the. Please zoom and see the theorem once again. If you have any doubt, ask me. So